This video covers AutoGluon for tabular problems. There's a project called Spaceship Titanic on Kaggle. So I'm going to use this competition to demonstrate AutoGluon's powerful performance. Just so you know, it can be a bit tough to use AutoGluon in the Kaggle environment. I recommend learning it on your local setup like your PC or using Google Colab instead. AutoGluon is one of the AutoML tools that automates typical machine learning processes. When developing a machine learning model, we usually need to refine the data, select the model, and do some tuning. This kind of work takes time, but AutoML tools like AutoGluon automate these steps. Among many AutoML tools, AutoGluon might be the best choice because it's free and based on PyTorch and actively updated. To install AutoGluon, just type the command pip install AutoGluon. This command installs the full package, which includes modules for tabular data, text, vision, and more. But in this notebook, I only need the tabular component, so to save time and resources, I'm going to use this command. Alright, here's the log showing the AutoGluon installed. When installing AutoGluon, you might see an error message like could not find the version that blah blah blah. I actually encountered this error while installing it in the Kaggle. This error is caused by an internet connection issue. In this case, you need to click there. You can find this option in the settings menu of the Kaggle notebook. If you cannot find the option, you might need to register your phone number with your Kaggle account. Let's use AutoGluon. Here's the import. I prepared the separate data iris. Then we wrote and processed data. I guess the last is pretty standard. Let's focus on the key point. This line is training part of the AutoGluon. We set the label and data and presets. I'll explain more about the presets later. Once training is over, we can evaluate and predict like this way. So, how does Tabular Predict work? Let's take a look. It builds models using many different algorithms. For example, here we have a k-neighbor algorithm. This is one of the k-neighbor series, and here's another type of the k-neighbor algorithm. This one is neural network. Then we've got like GBM and CapBoost, random forest, or some extra tree. For binary classification problems with tabular data, tree-based algorithms tend to perform really well. And as you can see, there are many tree algorithms here. Makes sense. And there's model called Weight Ensemble L2. It's an ensemble model. And as you know, ensemble models are made up of multiple different models. Here, AutoGluon tried to create an ensemble model based on the ones it already built. But in this case, it's just using one of them. Even though it's only using a single model this time, testing with ensembling is always worth it. It can get complicated and take a lot of time, but AutoGluon automate all these steps. How does that sound? Pretty simple and intuitive, right? Okay, let's move on. To be more practical, I'm going to demonstrate AutoGluon with the Spaceship Titanic dataset. Data preprocessing is the most important part of the machine learning. It includes handling null data and categorical data. This task can be pretty annoying, but with AutoGluon, you often don't need to worry about data preprocessing. You can just use it like we did in the previous examples. This command is pretty clear and intuitive. The label and even metric means exactly what you think. But preset option is something special. By simply setting this option, you can control AutoGluon's performance. Best quality means AutoGluon produces model using auto-stacking, ensembles, and so on for the highest quality. There are several options, and you can check the details in this link. Then, let's check out the results. The score is 0.79588. It's not that low. Honestly, I tried the neural networks and several other models, and I even tried ensembling 2 or 3 of them. Compared to those attempts, this score is pretty high, but AutoGluon easily matches or even beats my models. However, my goal was to get a score over 0.8. Let me explain how I achieved that. In short, the answer is the data preprocessing. Before, I used AutoGluon without any data preprocessing, but this time, I'm going to use the data preprocessing, specifically feature engineering. This comes from the Getting Started notebook, officially provided by the competition. The feature I'm focusing on is the cabin column. The cabin column contains mixed data. So I split the data like this, just like in the Getting Started notebook. And I just used the tabular predictor like before. With that, I was able to get a result over 0.8. Just a bit of simple data preprocessing can lead to better performance. This is a very important point. Even though I'm discussing AutoGluon, data processing is always essential. You might improve the model performance through hyperparameter tuning, but it's tough, because AutoGluon's best quality presets already rely on complex processes like boosting, bootstrap, stacking, and so on. As a result, AutoML is a great tool. It automates the annoying parts of modeling and tuning. In the future, I believe AutoML will be essential, but for now, it's more of an assistant tool that gives insights. Thank you for watching the video from the $1 Lab. At $1 Lab, we take on projects like this one starting at just $1. Feel free to reach out through the contact info in the description. Hope you found this video helpful.